All right. Hi, everybody. I wanted to go over the notes for the meet type problems. So the question that's guiding these notes is how can you calculate where two objects will meet? So if two objects are traveling either towards each other or in the same direction, how will you figure out when they meet each other? The big idea is the motion of the object can be modeled, right? Note that I messed up the notes. I apologize. It should say the motion of the object can be modeled by by equations, which can be used to predict their motion. So, meaning like we can use math to basically look at a pattern of an object and figure out when it's going to be where or where it's going to be when. So for objects moving at a constant speed, you can use the following equation. So this is just the regular um, right equation that we've been using in class. So x is equal to velocity times time plus x naught. So where x is where the object is at time t, v, so right, the x is the position of the object at any given time. V is the object of the object, and we would want to make sure we include a negative sign if the object was moving in the negative direction. So that usually means if it was moving to the left, you would want to have a negative sign there. P is the time since the beginning. So whenever we call the beginning, so usually when the two objects would leave, uh, right, it's the time since they left. And then X naught is the initial position of in each object. So that's the notes. So let's take a look at an example problem here. Okay, so we have, let's see here, right? You realize that you left your physics homework at your friend Sam's house. Sam lives 3.1 miles, which is 5,000 feet or meters, right? 3.1 miles is 5 kilometers. If you're a runner, you know that. But then, so 5 kilometers is 5,000 meters from your house. You decide that you will meet in the middle. Uh, you both leave at the same time. You can walk 3 miles per hour, which is 1.3 meters per second. That's the number that we're going to be using, and Sam walks 5 miles per hour, which is 2.2 meters. So we're going to be using the metric system, right? So we're going to use the 5,000, the 1.3, and the 2.2. So the first thing it says is draw a picture. It's often really useful to draw a picture to show what this looks like. So we're going to just, right, let's just kind of imagine this as a number line here. And let's say this is your house here. And right, and then here is Sam's house, and Sam's house is right 5,000 meters away. So if we kind of picture this as a number line, then right, the positive numbers, this is the positive direction to the right here. This is the negative direction to the left. And so let's also just go ahead and draw the velocities on there. So you walk 1.3 meters per second that direction, and Sam walks 2.2 meters per second that direction. Now, because Sam is walking to the left towards the negative direction, that means that he's got a negative velocity. So that's a negative 2.2, really. That's a pretty good picture. Let's move on to the next part. It says, how long will it take you guys to meet up, right? So let's write an equation for you, and let's write an equation for Sam. So these equations are going to follow the form of, right, x is equal to vt plus x naught. So let's write an equation for you. I'm going to write x subscript u, the letter, to represent your position. So your velocity is 1.3. Leave the t there because we're going to need that variable, plus your initial position, which is 0. So that's your equation. Let's write Sam's equation. I'm going to write xs, s for Sam, and equals his velocity. His velocity is negative 2.2 t, plus 5,000 because Sam starts at 5,000. All right, so now we got our equations here. And what we really want to know here is, when do you guys meet up? Well, you meet when your position is equal to Sam's position, right? So meaning when your position is equal to Sam's position. So when you guys are walking this direction, the time, right, when both of you have the exact same position, that is when you meet up. So what we can do is, right, we have an equation for your position. We have an equation for Sam's position. So we just set our equations equal to each other. 1.3t, I can leave off the plus 0, obviously, is equal to negative 2.2t plus 5,000. So, where'd my blue pen go? Well, there it is. So now to solve, we need to get both, right, the t's on the same side. So I'm going to add 2.2t to both sides. So that's going to give me 3.5t on this side is equal to 5,000. Right? Then divide by 3.5 to get t all by itself. Got to do it to both sides. So then you're going to get that t is equal to, it's going to be a pretty big number here. It's for 1,428.6 seconds. You don't really need the 0.6 seconds, but I guess since I forgot to round, we have that. So that's how long it takes for you guys to meet. In case you're wondering, like if you're like, oh, that seems like a lot of seconds, it's 23, 24 minutes basically. So that's approximately how long that is, just in case you're wondering. We don't need to know that in minutes, but just mentally if you're wondering what that means. So that's the hard part. That's the hard part of this type of problem, is figuring that out. Once you have that done, right, it's asking how far from your house will you be? Simply take this time and plug it into the equation for you, right? So how far from your house? Well, that's what XU is, right? XU is how far you are from your house. So that's just going to be 1.3t, right? That's your equation. Take the t, plug it in there. So and that's, you're going to be 1,857.1 meters away. And that's how you solve that. So sometimes I won't split parts B and C up into their own individual parts. So sometimes I might just ask you, how far from your house are you? And you basically solve for the t first and then plug it in. So just know that sometimes I'm not going to ask you for the time and then the distance. I might just ask you for the distance. However, the how you go about doing the math is exactly the same, right? I just don't break it into two pieces for you. So I hope that makes sense. We'll be doing more practicing in class, so you'll get some more practice, but hopefully that makes a certain amount of sense. So thank you for watching.